So thank you everyone for coming in today, both on Zoom and in the classroom. I'll just start off with some housekeeping. I hope you all know there's a test on Thursday, and that that one of the questions is this task write-up thing, which I put on Wattle last week. So you just have that ready to copy and paste into the test paper, and it's not a. Yep.
Is there any word limit on it?
No, but it's not a big essay. I think I said no more than a page. Yeah. So.
Okay.
Yep. So we don't want it to be too much of a big deal.
Do we have to put reference on the?
I don't think so. Don't treat it like that. It's really just to test. The idea of it is to give you a chance to answer a question about something that's important in the course, where you can have a bit more time to think about it. You don't feel you're under too much exam pressure. That's all. So that's the main thing. Today I'm probably going to end up spending most of my time talking about multi-criteria decision making, and that's relevant to the task write-up and probably one or two other questions in the test. I'm going to introduce some ideas today, particularly about measurement, which I am not going to be testing you on this week. Okay, and I'll make that clear as we go. They're very important ideas that we'll spend quite a bit of time on later in the course, but in my experience it's good to start introducing them earlier on, because they often take people a bit of a while to kind of absorb and become comfortable with. And multi-criteria decision making is a good topic to do that with. So let me get the screen shared and we'll get going. Hopefully. What is going on? Oh dear. That's better. Where are we? All right. So I'm just setting the screen up here. Get just a few little technical things I need to get sorted out here, so you'll just bear with me for a moment. Okay. All right. So. Okay, so I've got the screen shared there. I've got the chat up there. So one of the jobs of the people who are here in the room with me is to let me know if there's a question or something coming from people on Zoom, because the screen is behind me. Okay, so let's get going. So I made two little explainer videos over the weekend that are relevant to questions on the test. So one was about multi-criteria decision making, where I covered this initial bit here, so I won't go through this bit in detail. And the other one was about how to manually do a 5-number summary, which you will be tested on exactly once and never again. But I want you to do it once just so that it'll help you get that kind of spatial understanding that I think is important. So what I explained in the video. Yes, go ahead.
Is that to do with the whisker plots that you were talking about last week? That 5.
Yes.
Set?
Yes, I'm not going to ask you in the test to draw one. I'll ask you to interpret them, and I will ask you to calculate. There'll be one question which involves calculating a 5-number summary and identifying outliers. So the video I posted on whenever it was yesterday, I think, works through 2 examples of that, and then gives you some practice examples with the answers.
Okay.
Okay. Good. So look. So in the video about this, I talked about how we set up one of these spreadsheets and so on, and I'm going to go over that again today with a different scenario. But I'd suggest you have a look at the video because it might help with your task write-up. And for those that are interested in seeing how the spreadsheet works, I explained it. It's fairly straightforward. The main thing that some people may not be familiar with is this sum product function, which is a very useful thing to know about. So what I want to do now is move on to sort of more of the issues around multi-criteria decision making. So there are 2 things, sort of big picture ideas I want to emphasise here. One is this concept that is called satisficing, and the other is I want to start introducing the idea of measurement. So, but let's talk about the general picture of multi-criteria decision making. It is just a tool, but it is one that is commonly used in situations where we are confronted with bounded rationality. We can't make a perfectly rational choice because we don't have the time, resources, processing power to consider every alternative, to figure out even what all the alternatives are. We don't necessarily know what all of the preferences are or the possible consequences of our decision. And so what we do is we adapt, we compromise, we try to come up with some way of doing it that is reasonably practical given the resources and time that we have. Now, satisficing is a term that was invented. It was invented by Herbert Simon, who also invented the term bounded rationality, and he subsequently won the Nobel Prize in economics for those ideas, and he explored them with his colleagues in enormous detail. But the original idea of satisficing is it's not a negative thing to satisfice. It's a necessary thing in almost every situation. We rarely ever make a decision where we actually can be purely rational about it. But some people use it in a negative way, in a pejorative way. They say, oh, he was just satisficing, he should have been doing a better job. The real distinction is this: you can satisfice in a lazy way. So the way to think about it is, in a given decision-making situation, you're operating under constraints. You've got limited resources and time and knowledge and so on. So what you do is you basically get an idea of, okay, what resources and time and so on can we bring to this decision-making process that are reasonable, and how well can we optimise the decision-making given those constraints? So that's the key thing, is it's not to be too lazy about the decision-making. So that translates into things like a lazy decision-maker will overlook alternatives that he could be taking into account, or not do a thorough job of working out what the preferences are, or use some silly decision-making rule. Okay, that's really what this is about. So we all satisfice, we do it all the time, it's necessary, but one of the keys to good decision-making is trying to make the best of what you have to work with. So that's that idea. The second thing is, and I will go through this in a bit of detail, is you can think of a tool like multi-criteria decision-making as a process of evidence gathering and measurement. And I'll explain what I mean by that, but you are collecting evidence about things, about what the alternatives are, what the preferences are, you know, what the consequences are, and then you're using some rule calculation to come to a decision. And look, these multi-criteria decision matrices, they're not the only way of doing it. There's a number of other techniques, but they're really common. And there's a huge amount of research. I mean, there's journals dedicated to multi-criteria decision making. There's all sorts of fancy techniques, and a lot of the research is frankly pretty abstract and theoretical, or it's very minor tweaks to a process. The model that we're going to be looking at, the weighted additive model, is not, I think, the best one you can use, but it's got some advantages. The main one is it's simple. Okay, it's a pretty simple calculation involved. And that's important even if you happen to be a person who's right across the spreadsheets and the mathematics and whatever. In the real world situation, you've got to be able to explain to stakeholders how you did it. It's got to make sense to them. You know, I can show you really complicated formulas that you can use in spreadsheets for decision making, which is, you know, a little bit better than the weighted additive model. But if you're in a real situation where you're facilitating a decision in an organisation and you start talking about, you know, logarithms and geometric means and and things, you might actually get a negative reaction from stakeholders. They might think you're trying to, you know, confuse them or trick them or something. So you have to be mindful of that. Sometimes, you know, we actually end up using simpler techniques than we wish we could use because we have to be able to explain to the important people how something works. So we're going to look at a very common example, and this is staff selection and recruitment process. So this is a situation where some form of multi-criteria decision making is almost universally used these days, particularly in larger organisations. If it's a small startup, you know, the CEO might just say, oh, I like this person, I don't like the rest of them, I'll take him or her. But in larger organisations, some sort of MCDM procedure is nearly always used. And many of you will have been caught up in one of these, either as a job candidate or you may have been involved as part of your work in sitting on a selection committee or helping organise one or sifting through resumes and so on. So the alternatives in this situation are the job candidates. And in a pure, you know, if you're purely in the pure rational procedure model, you've got a job and you would consider every person in the world who might be able to do it. But of course you don't know who all those people are, and it's not practical to consider them, and many of them, you know, you wouldn't be able to find them. So invariably what happens is some kind of search and shortlisting process. So you advertise, you list them on websites like seek.com, you might use social networks to try and get recommendations of people. And if you get a lot of, the end result is you want to interview a few people. And depending, how many you interview depends on the job and the, you know, if it's a big recruitment exercise it might be hundreds, but often it's a much smaller number. It might be that you have a selection committee and they're available to meet for one day, and you work out on the basis of that the most they're going to interview is 10 people. So even if you get 1,000 applicants, you've somehow got to narrow it down. So the first area where you can get into lazy satisficing is not doing a good job of shortlisting. Or not doing a good job of advertising. That's one thing that can go wrong. But the next step is this shortlisting process. And shortlisting is a measurement procedure. And this is where we start to get into ideas about measurement that are not, they're not part of most people's ordinary thinking. So we've looked a bit in the stuff about exploratory data analysis. We've talked about quantitative measures. Okay, scores for skateboarders and weights of chickens and so on. Marks for the course last year. So they're all more or less quantitative measures. But a different kind of measure is classification. So some of the things we looked at, some of the tables of data we looked at had what we call categorical variables, or sometimes called nominal variables. So with the skateboarders, for example, one categorical variable was their country. Okay, we had some from Japan, one from America, one from Brazil, one from China. So the country of a skateboarder is a categorical variable. It's a classification. We're giving a name to some attribute of people. Now, in that case, those cases are fairly straightforward classifications. It's common knowledge what country a particular athlete belongs to. There are other cases where classification requires human judgment or skill, and it's fairly easy to make mistakes. So shortlisting of candidates for a job is an example of that. A fairly common setup with shortlisting is classifying the applicants into maybe three groups. So your measurement will take a candidate and say, you belong to this group, or this group. So one group is the immediate rejection. Okay, you're not going to consider them any further. They haven't got a chance of getting the job. They maybe miss some essential qualifications or experience that's needed, and so they will eventually get a rejection letter. So that's one category. Then you've got at the other extreme, you've got another category, which is people who will actually be interviewed. And then in the middle, you might, in many situations, you have a category which is people who are qualified for the job. They're not good enough to interview, given the rest of the candidates that are good enough to interview, but you might want to offer them a job later on. So they get a different letter. They don't get a rejection letter, they get a letter saying, look, we're not offering you an interview this time, but we'd like to keep your details on file in case something comes up. So a really common thing that happens here in Australia in large organisations is this. Somebody leaves the organisation and somebody below them starts acting in their job. And particularly in the government, that can drag on for like 2 or 3 years until they eventually get permission to advertise the job. And then when it's advertised, almost always, regardless of how they compare to the other shortlisted applicants, the person who's been acting in the job will be interviewed. And often they get the job. And then when that happens, that creates a vacancy a level below. And often they get offered to the people that were shortlisted for the job that's just been filled. That's a fairly common scenario. So what happens with that kind of categorical measurement, though, is it involves judgment. And the judgment can be biased. Okay, that's one thing that can go wrong with it. And this has been very extensively studied with job applications. Okay, so people, here in Canberra we have a member of Parliament, Andrew Lee, who used to be an economics professor. And one of the things he used to do was what we call audit studies of recruitment. So what he would do is he would send applications for jobs. These were large recruitments where organisations were recruiting large numbers of people and there would be thousands of applicants. And what he would do is prepare applications and resumes, and he might submit resumes for that purportedly from a man and from a woman that were identical, and a whole bunch of those. Or he might submit ones which had Anglo-Saxon names or Chinese names or Indian names and submit those as well. And then keep track of what happened. Who got rejected, who got shortlisted, who never heard back. And then statistically analyse those to see whether there was a bias. And I regret to say in many cases there was a bias. So that is a failure of measurement, because what's actually happening there, you've got, this is sort of quite hard stuff to think about in a way, but when you're shortlisting, when you're categorising, what you're actually measuring is you're doing a preliminary measurement of the job suitability of these applicants. So job suitability is an example of what we call a latent construct. So what that means is, it's not something, you can't stick a thermometer in someone or something or an instrument to tell if they're suitable for the job. It's a kind of invisible characteristic of someone that's made up of typically many components. But in the business world, we're measuring latent constructs all the time. Job satisfaction is a latent construct. Customer satisfaction. Turnover intention to leave a job. These are all latent constructs. We measure them all the time. So job suitability is one of them. So what you're wanting to do in this early triage process in the shortlisting is you want to make sure that the people that get into the shortlist are the sort of best subset of the people who applied. And you don't want people to be rejected who actually are good enough to be shortlisted, for interview. So there's two things that with measurement, any type of measurement, what we're shooting for is what we call accuracy. Now, accuracy has a technical meaning. The language here gets a bit weird, but there is an international standard that relates to the terminology of measurement. And accuracy has two components. So one of them is called precision, and the other is called trueness. Where the language gets a bit funny is a lot of people use the word accuracy to mean trueness. So let me explain what trueness is first. Trueness, the idea of trueness is actually pretty simple. It is measuring the thing you say you're measuring. So when I was at school, we were always trying to think of ways of getting out of going to school, and one of the ways was to fake having a temperature and say you were sick and go home. So we would come up with schemes to sort of, drink hot tea and stick a thermometer when the thermometer went in our mouth or whatever, and fake having a temperature. Well, what happens? That's a failure of true measurement. You're not measuring, if you stick the thermometer in the kid's mouth and the kid's sneaking hot water or something you're not measuring the true thing. You're measuring a mixture of the water and the kid. Okay, so that's the kind of idea. So if you have shortlisters who are biased, they're not being true in their measurement. They're not measuring the true thing. Okay, it's a failure of trueness. The second thing that makes up accuracy is precision. And precision, later on in the course we'll look at there are a number of ways of looking at it, but the way I want to focus on at the moment is a measurement is precise if you repeat the measurement and you get essentially the same answer. Okay? So if you're taking temperatures and you've got an imprecise thermometer, let me illustrate it with a thermometer. If you put your thermometer into something and it gives you the correct temperature, then it's a true measure. If it always gives you the correct temperature, if you put it in and you just get the same measure all the time, then it's precise. But you can have a thermometer which is precise but not true. So a few months ago I went around my house and we have collected over the years quite a few of the kinds of thermometers that you measure kids' temperature with. This happens when you have a kid, you get tech thermometers and you lose them and then you find them again. And just as an experiment, I thought I'll just see how accurate they are. So I happen to have a thermometer which is very accurate, to about 1/10 of a degree. So what I found with these medical thermometers was they were all not true. None of them actually measured. They're all out by about somewhere between around about 1/2 a degree. One of them was out by more than that. So the trueness is not great. The precision, however, was quite good. And what that means is if I took repeated measures with most of these thermometers, they gave the same answer. Okay, so they were not true, they were not giving me exactly the right temperature, but they were at least precise. And that's an important thing with a thermometer that you're using to measure a kid's temperature, because what you're mainly interested in is the temperature going up or going down. So if the thing is precise, it's and not too untrue, then it's probably okay. So with this initial triage process, what you want to aim for is trueness and precision. Now, in that context, what precision would mean is something like this. Imagine you get a stack of job applications and you have two people whose job it is to sort through them. You can test the trueness by putting them in different rooms, each with a copy of the job applications, and saying, okay, you go through and classify them as reject, shortlist, or maybe later. And if they come out with exactly the same classifications, then you can be pretty happy about things. But if they don't, then you've got a precision problem. Where we encounter this in universities all the time is with marking. Okay, so if you've got a large class and you've got 6 tutors who are doing the marking, as a course convener, you've got to pay close attention to this. You've got to make sure that the marks that are produced are true in the sense that they're reflecting the achievement of the students on the grading scale that the university uses. And you've also got what you would ideally want is that if tutor A marks an essay, say, and tutor B marks an essay, they'll come up with the same mark. Now the reality is that's unlikely. I've done studies of this, and the difference tends to be, it varies, but 1/2 a grade is not unusual. So what you have to do is find ways of compensating for that. There's a number of ways you can do it, and it's a standard kind of thing that we do, but it's important. And there have been many studies done which have done things like this. They'll get someone who is an experienced marker, a lecturer, and they'll give them a bunch of essays and say, hey, mark these, maybe with a rubric. And then a year later, they give them the same bunch of essays and say, mark them again. And a difference of a grade is not that unusual. Certainly 1/2 a grade is in the ballpark. So the precision of marks generally is probably, to be honest, plus or minus 5 marks. And what I mean, I don't mean by that when you get marked in a course that you might be disadvantaged by 5 marks. What I mean is that when we talk about precision there, we're talking about as a reflection of your achievement. The marking process is not perfect. Okay, it's as good as we can make it we try to make it as good as we can make it under the circumstances. When I mark your test, I will actually calculate the precision. I'm not sure if I'll tell you, but I probably should. But I always check it. I always check my own consistency in marking. So, okay, so let's move on to the next bit. So that's the selection of alternatives. Ordered. So let's just recap on measurement a bit here. So we've talked about quantitative measurement. So all I've talked about with quantitative measurement so far is the idea that with a measurement is quantitative if it makes sense to talk about adding and subtracting the data. Now, categorical measurements, it makes no sense to talk about adding and subtracting. They're just classifications. Even if we use numbers to represent them. So we might say category 1, category 2, category 3. That commonly happens, but you don't add and subtract those numbers. Then there's a type of measurement which is, we can think of as ordered categorical. In the behavioural sciences, they tend to call it ordinal measurement. And this is a very tricky area. We'll go into this quite a bit later on. But the idea is this. With our triaging of job applications, you could think of that as being an ordered categorical measurement. So the people that are categorised as being suitable for interview, they have a higher level of this latent construct of job suitability than the people who are in the maybe later category, and they have a higher level than the people who are in the reject category. So we could say that's an ordered categorical measurement. But we can't add and subtract those things. Even if we give them numbers, we could say category 3 is the interview group, and category 2 is the maybe later group, and category 1 is the reject group. You can't do maths with those numbers. They are just numbers being used as names. Example I've got in the notes was about this rather extraordinary result for the 100 metres in the Olympics. I don't know if anyone watched this, but you've got a gold medal, a silver medal and a bronze medal. That's an ordered categorical measurement. Okay? But it makes no sense to say things like, a gold medal is worth 2 bronze medals or whatever. In this particular case, you can see how close they were. The difference between the bronze and the silver was 2 seconds. And I think, I can't remember now, the gold was about, 8 seconds, something like that. Tiny, tiny, tiny differences. So it makes no sense to talk about adding and subtracting those. Now, what makes ordinal measurement, when I say it's tricky and whatever, is later on in the course we will see that what happens when you teach this stuff is you say to students, because I remember being totally confused about this when I first was taught it. So the lecturer will say to you in your stats course, you can't add and subtract ordinal measurements. And then later on, they'll give you data from a survey where they're adding and subtracting ordinal data. So there are special circumstances where we do it, and the outcome is quantitative. But just bury that thought for the moment, because I don't want to confuse you with it. I'm just giving you a warning, because that's actually probably the most confusing part about this whole measurement thing, and it's very, very relevant to stuff that we do in business and organisational behaviour and so on. Okay, so it's not as clear cut as it sounds, but for the moment, just think of ordered categories like that. What you're saying is that something has more of something than something else. So, when we're marking assignments or when you get your marks for your course, well, let me give an example with marking essays, okay? The preferred way of doing it these days is you have a rubric, and each essay you fill out things on the rubric and you do some sums. You're actually adding up ordinal numbers, but we won't go there. But the traditional way of doing it was you sat down with a pile of essays and you read them and you put them into piles. HD, D, credit, pass. And then when you were satisfied with that, you then looked through the piles and you figured out, okay, where, this is the distinction pile. You look at an essay and you think, where do I put them between 70 and 79? Okay, and you make a judgment about that. So that's the traditional way of doing it. It turns out that there are people who are really good at doing it that way. So there have been studies that are done where they've compared rubrics with, and there are some people that are really good at that. Most people are not. Rubrics make it more reliable. So that's why we encourage the use of them. Okay. A bit more terminology. Okay, so this is, oh dear. So I'm using the terminology I've been using, so accuracy equals trueness and precision. That is terminology that's mainly used in physical measurements, measuring length and weight and so on. In the social sciences and the behavioural sciences, people talk about validity and reliability. And reliability is the same thing as precision. There are different ways of measuring it and so on, but reliability is basically the same idea as precision. So if you have an IQ test, for example, so you develop an IQ test, the idea of reliability is that if you give somebody the IQ test and you get a score, and then 6 months later you get them to do it again, you will get about the same score. Okay? And that's the same idea as precision. Validity is a little bit trickier because the basic idea of validity is that your questionnaire is measuring intelligence and not something else. And this has been a big issue with IQ tests. So IQ tests of various kinds have been shown to be sensitive to language skills, socioeconomic status, and various other things. There are questions about the trueness of them. Are they measuring your intelligence, or are they measuring your English language skills, or are some of the questions in them things that only people from a certain socioeconomic level would really be able to think with and make sense of? So these are validity questions. But what's happened in the social sciences is people have come up with a whole lot of different kinds of validity. So I couldn't find it today, but there's a website somewhere, I think at Oxford University, where a guy keeps a list of these, and there's well over 100. So there's face validity, there's criterion validity, there's emic validity, there's lots and lots and lots and lots of them. And if you're studying social sciences, you will have come across some of these. So that tends, in my view, to make things rather confusing, particularly when you're new to these things. I think it's better, particularly when you're starting out, to learn to think in terms of trueness and precision, because that's the fundamental underlying idea. The reason you have so many types of validity in the behavioural sciences and the social sciences is that most of the time you're measuring latent constructs. Okay, you are measuring satisfaction, ego depletion, intelligence, you name it. There's thousands of these latent constructs. They're all things that you can't measure physically. So, trueness, are we measuring the right thing? Are we actually measuring the thing we claim to be measuring? And precision, is the measurement repeatable? If we repeat the procedure, would we get the same result? Now, one way to help with this kind of thinking is to think of measurement as a procedure. So if you're classifying job applicants, the actual procedure, the measurement procedure, involves the whole business of the applicants writing the applications, writing their CVs, sending them to you, having your staff member read through them and sort them, and that's the measurement process. And that's where you use that to think about precision and trueness. So, from a critical thinking perspective, the big thing I want you to take away is, firstly, recognise when you're doing measurement. Because very often people don't think very much about this. If you've been in the workforce for any period of time, you probably will have encountered a boss or a CEO or somebody it's often a man who sort of beats their chest and carries on about how nothing counts except numbers. Metrics are everything. If it's not measured, it's not of any interest. But what you find with those people, and we've had, our previous Vice-Chancellor was like that. I've had a number of bosses over the years. In my experience, those people often have not got a clue about good measurement. And they come up with a whole lot of KPIs and things, many of which are pretty useless as measurement. So it's an important capability, I think, to recognise when something is a measurement or is pretending to be a measurement and then being able to judge whether it's any good. So anything that's called a KPI is probably a measurement, for example. But they come up in lots of situations. So what you need to do is, critically examine the trueness and the precision. So a very common situation is performance appraisals. Okay, so your boss usually, sometimes your peers, they get to rate your performance. And it might be on a scale of 1 to 10 or 1 to 5 or whatever. That's a measurement. And it's a measurement that has consequences. And a lot of those measurements are not very well designed and they're not evidence-based, and but they have significant impacts on people's lives. Some of them are pretty good. Some of them are the result of serious research, but some of them are just made up. And, they often just probably don't work. And then you need to be clear about whether measurements are quantitative or not. Because if they're not quantitative, and people start doing maths with them, and this happens a lot with things like performance evaluations and so on, people would come up with these weird and wonderful formulas, and they're nonsense. Because you're dealing with numbers that actually don't make sense to multiply and divide and so on. So it's a good thing to learn to be a bit critical about these things. Of course, you're not necessarily always going to be able to do anything about it. Particularly at an early stage in your career, you're going to have these things imposed on you, but good to know about them. Now, going back to multi-criteria decision making for job selection or for any purpose, there are some desirable characteristics of the selection, the criteria. So let's talk about those. So the selection criteria, go back to my diagram, where have I put it? Oh, it's the next page. Okay. So in this example, we've got 7 criteria. They are sort of summary headings. And so what happens in a typical job selection committee is there'll be some process for working out what they are. It's usually worked out prior to advertising, because what you normally do is you say to applicants, here are the selection criteria, you need to write a response to them. And as I'm sure many of you know, there's all sorts of websites and training courses and probably consultants to help you do this. And but the selection criteria themselves are chosen by some process. And I've been on selection committees where the selection committee met, worked out what the criteria were, and then advertised and so on. Most of the ones I've been on, the criteria have been worked out before the selection committee was appointed, and they have come from a document called a position description or something like that, which is a statement of what the job is about. But there are some desirable characteristics for these criteria. So one is they should be things that you can think of a way of measuring. Now, by measuring, essentially the measurement is going to be some sort of rating, and it will be informed by answers to interview questions. So what selection committees actually do is, having got the criteria, they will sit around and have a meeting where they work out what are the questions we're going to ask and who's going to ask them. And I believe my colleagues who teach HR assure me that there is solid research to say that you get better results when you do actually have a predetermined set of questions and you ask everyone the same questions. So that's something that's worth knowing. The other desirable characteristics from the point of view of how multi-criteria decision making works is you want those criteria to be what we call mutually exclusive and comprehensively exhaustive. When I say we, that's a term that was developed in the 1950s at McKinsey and Co. They pronounce it MESI, but the person who invented it calls it MES. I was originally taught it as the NONG principle, no overlaps, no gaps. So the ideal, what it means is just this. You want your criteria, your set of criteria, to cover everything that's important. Okay, you want to choose a selection criteria that covers everything that's important. And ideally, you don't want overlap between them. You want them to be asking about or looking for different things. Now, what happens in the real world with selection committees sometimes is a bit of office politics gets involved. So I've seen cases where, remember I mentioned that you often, this is particularly true in government and university jobs, you have somebody acting in the job for a long time. Often you'll have somebody, usually the supervisor, who wants to keep the person, trying to influence the selection criteria to include something that favours the incumbent. And the way that's usually done is they try to add in highly weighted selection criteria that are very specific to the details of the job, the work in the job, or the particular qualifications of the person who's got it. So that happens sometimes. I've also been on selection committees where somebody powerful in the committee has tried to change the selection criteria or the weighting during the selection process, during the interview process, to prefer a candidate that they preferred. So, you know, biases of various kinds can come into this. You just need to be aware of this with any decision-making process, not just job selection. You know, the earlier one I showed you about project selection, that's another one where there can be a fair bit of office politics involved in deciding what the alternatives are that are actually considered and what the criteria are. So we need to be realistic about those things. I've got a list here, just an illustrative list of the sort of typical kinds of things you see under those headings. So if you're sitting down on a selection committee, you might have lists like this. So administrative competence will be divided into a few things. And what you do is what you're aiming for is you want to see whether, when you're putting these together, are these things that we can actually make a judgment about in an interview situation? Does it make sense? And what sort of questions would we ask? Now, increasingly in the last, I guess, 20 years or so, we've had other things added into the process besides interviews. So it's not uncommon now for job interviews that you might turn up and be, I mean, I've known cases where people have turned up for a job interview and part of the process is they get put into a group with other job applicants and given a case study or something, and they've got to go and work on it, and then they probably get videotaped with a secret camera to see. I don't know. But a bit of that goes on, or just you're given a case study and you've got to write something and come back with it the next day. Psychological tests of various kinds are quite common these days. Again, my HR research colleagues tell me that IQ is a very strong predictor of good outcomes in a job selection. But I've also talked to, I met 2 years ago, some academics who did a study in China at a company which made components for iPhones. And they were studying factory workers. And the jobs were very repetitive and not particularly highly skilled. And what they actually found was that IQ had a negative predictive effect on how long people stayed in the job. So basically, if your intelligence level was too high, I guess you would get bored and frustrated and leave or find a better job. But in that case, the situation was reversed. So these are other kinds of information that you can bring in, and you would just add them into the MCDM matrix. I mentioned that there are other kinds of calculations besides this weighted additive model. So the weighted additive model works well when all you're dealing with is ratings, okay, because they're all sort of on the same scale. When you want to start adding in things like IQ scores and so on, there are other calculations that do a better job. There's another one, if I was going to teach you another one, which I may give you an example of, I'll probably give you the spreadsheet. There's another version called a weighted product model. And the advantage of that one is you can have measurements of different scales on there. But for the moment, we'll just stick with this one. How are we going for time? Okay. All right. Now, the weightings themselves. So, the weightings play a very important role. Let me fix the lighting there. The weightings play a very important role in an MCDM matrix. Yes. So you need to put some effort into getting them right. Most of the selection committees I've been on, the criteria were predetermined, but the committee got to work out what the weightings were. But I have seen job advertisements where the applicants are actually given the criteria with the weightings. The question is, how do you determine them? And committees I've been on, people just sat around and discussed it and maybe wrote down their personal weightings and averaged them or something like that. But there are better ways, and I'm going to teach you, not today, a better way, which is a technique called comparative judgment. You have to use a spreadsheet to do it, but it's a very good technique. Now, the reason you might use something like this comparative judgment technique is that you want your weightings to be what we call ratio level measurements. So let me just go over the map again. We've got categorical measurements, that's where you classify things. And then we've got ordered categorical, like Olympic medals and grades for essays, okay, which are classifications, but they are ordered in some way. And then up to now we've had quantitative. So they are numbers, they are measurements where you can do addition and subtraction. Now what we mean by you can do addition and subtraction is this, and this takes a little bit of getting your head around. Quantitative measurements are expressed as numbers which are on the real number line. Okay, they are numbers, the kind of numbers that we're all familiar with. But the idea is that there is a correspondence between those numbers and the thing that we're measuring in the real world. And that if you carry out addition and subtraction, what you're doing with the numbers, with the symbols, reflects what happens in the real world. So IQ is a quantitative measurement. It is one that you can do addition and subtraction with. If we have a person with an IQ of 90, one with 100, one with 110, and one with 120, we can say correctly that the difference in IQ between the person with 90 and the person with 100 is the same as the difference in IQ between the person with an IQ of 110 and the one with 120. That's what I mean by addition and subtraction. The differences between the numbers are reflected in the difference in the real world. So this is the kind of thinking you've got to get used to doing, is not confusing the measurements expressed as numbers with the real world. So a good example of this is temperature. So in Australia, we measure temperature in degrees Celsius. And, you know, if it was 20 degrees last week and 40 degrees this week, which doesn't happen a lot in Australia, but I've been in parts of the world where it does happen. Most people would say, oh, it was twice as hot this week as it was last week. And what they're actually saying is the number that we use to express the temperature this week is twice as big as the number we used to express the temperature last week. In that case, the actual difference in temperature is about 7%. Okay, as a proportion, it's only a small difference. And that's because this is connected with the number that is associated with no heat, which is minus 273.15 Celsius. Okay. There's another scale for temperature called the Kelvin scale, where the absence of heat is actually zero. And so in that case, you could make claims about ratios, but you can't with the Celsius scale. And it's the same with IQ. We can't say that somebody with an IQ of 160, if there's such a thing, is twice as intelligent as somebody with an IQ of 80. That doesn't make sense. It doesn't make sense because zero IQ doesn't make sense. Okay. IQ, there are limits to the measurement range to start with IQ, but we actually don't know what zero IQ looks like because we couldn't measure it. Some people will say, okay, well, I've got a rock here, it must have zero IQ, but also the rock can't do an IQ test, so we can't measure it. So this is a pretty important idea. So what this leads to is we divide quantitative measurements into two categories. So we have what we call interval level measurements. So these are the ones where addition and subtraction of the numbers that we use to represent the thing we're measuring correspond mathematically to what's happening in the real world. And then there's a subset of interval level measurements where you can talk about ratios. So length is an example of a ratio, what we call a ratio level measurement. Something that is 2 metres long, with a number we use to indicate the length is 2, it is actually twice as long in the real world as something that is 1 metre long. And something that is 400 degrees Kelvin is twice as hot as something which is 200 degrees Kelvin. They are ratio level measurements. And the critical feature of ratio level measurements is that the symbol 0 in the measurement scale actually corresponds to 0 of the thing in the real world that you're measuring. Now, in the domain that we're interested in here, which is businesses and organisations and so on, there are many things that we measure that are ratio level measurements. You know, how much money you've got in the bank, how many employees you have. Those sorts of things are ratio level measurements. But there are also many things that we are interested in that are not, or we don't know. And so we can't calculate ratios. So customer satisfaction, we measure that all the time. And we come up with numbers, and if you do it properly, you will get interval level measurements of that, just like you will with IQ. But you can't talk about ratios. You can't say these customers are twice as satisfied as those customers. You can say these customers' score on our measurement scale is twice as big as the score of this other group of customers. Now, an example of where people go wrong with this is, and I've seen this, is where if you've used a call centre, if you called a call centre about something, pretty typically, a few minutes later, something will pop up on your phone which says, we'd like you to rate your experience. And some companies, many companies I think, use those ratings to calculate bonuses or commissions for the people who work in the call centre. And they often do it using formulas which assume that those ratings are ratio level measurements. They do multiplications and things with them, and that's wrong because they're not ratio level measurements. I am not going to test you on any of that this week. That's quite a few weeks away. But we do need, this is really important stuff to know about. Now, when I talk about using comparative judgment, that is a technique which you can use for rating things, which actually does produce ratio level measurements. So it's an ideal thing to use for working out the weightings in a multi-criteria decision matrix. And you can use it for other purposes as well. I had a student last year who was a senior official in a bank. He was in charge of compliance. I helped him use comparative judgment to come up with a weighted index of non-compliance events in the bank so he could track their compliance performance. It's quite good for that kind of application. So we will learn about that in the next couple of weeks, but I won't go into that now. So I'm just flagging this ratio interval thing. I find that a lot of people find it confusing, and as I said, I found it really confusing when I first, on the surface it all sounds pretty simple, but there's more to it. And I hate to say it, but that's actually not the only level of measurement. So last week in the tutorial we were looking at decibels. So decimals are another level of measurement, which is logarithmic, but we're not going to go there. Those ones mainly turn up in scientific applications and engineering and so on. Okay, now the ratings. So not a lot to say about the ratings, because the considerations there are pretty similar to the weightings. In a perfect world, we would use comparative judgment for the ratings, and then we would get lovely ratio level measurements all around, and it would make perfect mathematical sense to be doing all the multiplications and additions and things that we do in this table. In high stakes scenarios, people definitely do use comparative judgment for the ratings. So there are case studies, for example, where an NCDM matrix with comparative judgment has been used to work out where to put nuclear power stations or where to build dams and big projects like that. But it's fairly time consuming. So to do all of this with comparative judgment would take quite a bit of time. So more commonly what we do is we just have ratings, and a very common way of doing it is you say to people, look, for each candidate you've got 100 points, allocate them on the criteria. And the reason you do that is you're trying to get everyone to have their ratings on the same kind of scale, so that it kind of compensates for people who are really generous or really lenient or whatever. So it's a better way of doing it than just saying on each criterion rate the person out of 10 or something like that. If you do it in the rate the person out of 10 way, there's a mathematical trick you can do to get the same effect. You do what's called normalising the data. But I think that's a pretty, and it doesn't have to be 100. You could say it's 10 or 500 or whatever. But 100 seems to work. People are used to thinking in terms of 100 things to hand out. Now, there's one last little wrinkle on this, and that is the idea of essential unidimensionality. And again, I'm not testing you on this week, probably never. But it's an important thing to think about. So what it means is this. If we go back to remember I said earlier that what we're measuring in a job selection scenario is job suitability, which is a latent construct. And the idea of this whole matrix is that job suitability has, that these are the main factors or dimensions or whatever you want to call them in determining job suitability. That's what you're trying to do. You've come to, through some process, you've decided there's 7 things here that we're going to find out about for each candidate, and they are the most important things that determine job suitability. So for a measurement to be a good measurement, those 7 things should have, ideally, a characteristic that is known as essential unidimensionality, which is, it's a technical term, but what it means is that they are all reflecting the same thing. They are all reflecting job suitability in some way. Now, that can be pretty hard to achieve. Let me give you an example of a common type of measurement which fails that test. So all of you at school will have had, particularly probably in primary school, you will have had these math tests where, you know, they tell you that Fred has 7 apples and Mary has 6 apples and somebody else has whatever, and you've got to do some calculation. There's 2 dimensions to those tests. So one is being able to do the calculation, and one is being able to understand the question. So if the questions are worded in a way that requires a high level of English language proficiency, and there are people in the class, for example, kids who are, you know, English is not their first language, that what ends up happening is that the mark they get for the test is made up of 2 components. One is their math ability, which may not be measured very well, and the other is their English language ability, which the test is not meant to be measuring at all. So that fails the essential unidimensionality test. I've seen other examples that have been analysed where the math test had a whole lot of questions which were about racing cars and various other things which are stereotypical boys' activities, and the girls didn't get some of the questions because, you know, they didn't know what a carburettor was or something. Nobody knows what a carburettor is these days. But that's the kind of example. So this happens quite a bit. This is something that, again, you know, if you're designing tests, you can test for this. So this is, I've helped colleagues with big classes test for the effects of language proficiency in their exams, for example, to see whether there's a significant effect, and I've helped them test for gender as well. And one that I've done fairly regularly is test for the year level of the students. So who's done Management 1003? Okay. So I think I'd mentioned on the first lecture, that's a course where there's usually a bunch of 5th year double degree law students in there who are trying to boost their GPA, you know, at the end of their degree. So I've actually done an analysis to see whether the number of years of study has any relationship to the, is a significant dimension in the scoring. And no, it's not. Sorry? No, it may well be in others, but I'm just saying that these are actually things you can test for. So with these big high stakes tests like the NAPLAN and what do you call it, the HSC and things like that, they actually do that kind of analysis to make sure that, to try and make sure that the questions are as fair as possible. So it can be done. So I don't want to make a big deal of essential unidimensionality, but you need to be aware of it. If you look at the numbers here, if you can compare candidate 3 and candidate 4, they have almost directly opposite profiles in terms of how they score on these criteria. So if this was an essentially unidimensional set of criteria, you would say, well, there should be no difference between 3 and 4 on their suitability for the job. Their actual scores are almost identical, 14.5 and 14.6. But if you looked at their scores on the criteria and you thought, well, even though the score here is about the same, one of them is better than the other, then your criteria are probably not going to pass that essential unidimensionality test. That's the basic idea. Do you want to take a short break, or should I keep on? Short break? Let's take about 5 minutes, and then we'll do a little bit more of the data analysis stuff.
But I have questions on the unidimensional existence that you talk about. Is it like that, like 2 courses? When I take 2 courses, you cannot compare that I'm doing well at this course does not mean that I am doing well at that course.
So this is where that would be relevant, would be like working out your GPA, for example, or your weighted average. So we treat GPAs and weighted averages as though they are essentially unidimensional measures. Who knows? I think the argument would go, by the time you finish 24 or whatever courses in a degree, it all kind of averages out, and there's a latent construct which is your overall achievement of the degree learning outcomes that is essentially unidimensional. You see what I mean? That would be the kind of way you'd think about it. But it's well, see, most people are not, if they haven't learned about it before, they're not used to thinking about latent constructs. But we measure them all the time. You know, when we mark you, the mark you get for a course, we're measuring your achievement. What we're supposed to be doing with our marks is measuring your achievement of the learning outcomes. That's a latent construct. Okay, that's something about you and how you performed or learned in the course. That's what we're supposed to be measuring. This is the reason when I teach, I don't give marks for group work, because group work is not measuring the individual student who's going to get the mark. So what you have an immediate dimensionality problem. There's the group dimension and the individual component. So if you do a course where there's 40% group work, then 40% of your mark is a different dimension to the rest of it. And every year I test this against a bunch of courses, not that I teach, other people's courses, and the group work never correlates with the other mark. It's always a separate dimension. Now, again, this kind of can sort of even out, but my own view is I think it's better to encourage people to do group work in other ways than giving marks to them. So what I do when I'm teaching in China intensively, I have competitions, and everyone gets into the competition. They all want to do a good job. Another thing I do is I'll have an exam question which you just can't get a good mark on without having worked hard on the group work. If you're a student who doesn't participate, you're not going to be able to answer the question. So that's the kind of motivator. And actually, I find that works okay. I don't have to pay people with marks to do group work. But yeah, the basic requirements with measurement should be essentially unidimensional, and there should be what we call a monotonic, non-decreasing relationship between the score and the measurement, whatever it is, and the thing in the real world. So if I'm marking you to measure your achievement of learning outcomes, what has to be true is that the more you've learned, the higher your score. Yeah. You can't have it sort of going up and down. And you can test for that. If you've got a bunch of students, you can test for that. And I will, when I mark your test from this week, I will test for that. Just to check my own marking and make sure I'm doing it properly.
Thank you.
How are we going there on Zoom?
Okay, I just wanted to ask a question.
Shoot.
What topics are coming up in the next modules?
What are the topics that are coming up?
Yeah.
Where are we going from here? We've got we're moving on to we've got a couple of weeks of what's called the analytic hierarchy process, which is the kind of industrial strength version of MCDM with comparative judgment. So that's one set of topics. We've got a bit more exploratory data analysis to do. So the main thing that's remaining there from memory is correlation,
Okay.
scatter plots and things like that. And then I think we're largely done with that. Then we move on to, I can't remember the exact order now, but the big ones are, there's statistical inference, so that's where you are taking measurements from a sample like, you know, when you do a survey or something,
Yeah.
and you're coming up with numbers, the idea that whenever you take a sample, there's a certain amount of error, what we call standard error. And
Is that the t-test things?
yeah, I'm not going to use the t-test, but I'm going to show you something that it does essentially the same thing but with medians, but it doesn't involve you knowing about t-distributions and degrees of freedom and all that stuff.
Okay, what methods are you going to use?
So the method I'm going to use is basically if you take a sample and you know the median and the interquartile range, then you can do a little calculation, which is the interquartile range divided by 1.08 times the square root of the sample size, and that will give you the standard error for the median.
Okay, yes, yeah.
So it's a fairly, you know, the reason I do that is it just avoids us going down the rabbit hole of distributions and, you know, all that sort of stuff that you would do in a statistics course.
Yeah.
But it enables me to have students actually doing some, you know, giving them something they can actually use certainly in a real world situation. You probably wouldn't use that measure in a journal publication because everybody uses t-tests and over and all those sorts of things, but it's a perfectly viable method, gives you a reasonable estimate. So we do that. The one thing I do that is a parametric method, well, there's two really. So one is the formula for the standard error for proportions, and I teach that because it's actually really useful to know. But I don't go into binomial distributions and all the stuff that sits behind that. I just show you how to do it. And then there's another one I do, which is using run charts for statistical process control, where there's no calculations involved, but the underlying mechanism is a parametric statistical technique.
Okay.
So really, what I've tried to do in this course is the main thing I want people to take away is to actually understand what statistical inference is, so they can, you know, make judgments about data that's brought to them or about how to get data.
Okay.
So have you studied statistics? No. Yeah, well, most people do. But you know what I've found is because I've spent some time talking to statistics teachers in coming up with this. I mean, I've found that most students actually do get these big ideas about inference and so on. And statistics teachers tell me it drives them nuts that they get final exams and they have so many students who, you know, they can do the calculations, but they don't understand the principle. So, yeah. No, most people hate statistics.
I just had another question.
Yep.
I was like doing the question that you did on, I think, Thursday or Friday.
Oh, yeah.
But this is Thursday. I just did consumer choice thing, like the rational choice part. I just did consumer choice.
Yeah.
I hope that's all right. Just evaluating my cost benefit for different clubs.
Yeah, that's a perfectly good example. Yeah.
Okay.
Yeah.
Yeah, just for fitness things like centres.
Yeah. Oh, look, people. I've heard of people using this for, you know, choosing a life partner, and I'm pretty sure in the early days of online dating that the underlying sort of algorithms were basically just MCDM, and I think these days it's probably still MCDM, but with some artificial intelligence supplementing it, you know.
Yeah. I think that's all I had to ask.
Okay,
Thank you.
that's good. You're welcome, Sarah.
And I just have another question.
Yep.
I'm just wondering, like, so for the test is like all the content for week 1 to 3 always available?
It's week 1 to 3, but you'll see I've been telling you at various times things I'm not going to test you on. Yeah. So, Yeah, it should be fine. I'm not trying to make it a super hard test, but some of the questions will require you to think a little bit about what we've covered in class. Okay. All right. How are we going? Ready to go? All right, let's get back to some scary charts. So, what we've been doing with this exploratory data analysis thing so far, we're just looking at, really, we've been focusing on single quantitative variables. So we've looked at, marks from last year's course, we've looked at weights from chickens, we've looked at skateboards and so on. And what we've really got to in the end is the box plot, the 5-number summary, which is visualised with the box plot, and it serves a really useful function in general visualisation, but also in identifying outliers. Okay, and outliers are just very, very important to know about. The next step with a single quantitative variable is we usually want to try and get a bit more understanding of its shape. Now, the traditional visualisation that we used for that is the histogram. And I'm sure all of you at school had to learn to draw histograms, probably by hand, and also, I imagine, using Excel or something. So these have been around forever, and they were popular because you can draw them by hand. And there's even a version of them called a stem plot, which the histogram is drawn with the data, with the numbers. I learned that one when I was an undergraduate. I went on a zoology camp, and we didn't know what we were going to do. And when we got there, our job was to count spiders. Had to mark out a whole area of bush in 1 metre squares, and then we had to count the wolf spiders in the 1 metre squares, and we recorded them as these little stem plots. So when you write the numbers down, and what you actually see is a histogram on its side, but that's by the by. So the main issue with histograms is that what they tell you about the shape depends on your choice of the number of what we call bins. So the vertical bars in a histogram are called bins, and in most software that draws histograms, you can choose how many bins there are. Most software will use some sort of formula to have a guess at what would be an optimal number of bins, and it works reasonably well. But if you're using histograms, often what you will want to do is try different numbers of bins in case there's some feature in the data that is obscured by the default. So I've just given you an illustration there of what happens if you have different numbers of bins. So if you've got 1 bin, you're just going to get a rectangle, which is pretty useless. 3 bins, you can see there's not really, there's information there, but the information is not actually really correct. It doesn't really tell you what you want to know. As you add bins, at some point you get to a shape where there's too much information. Eventually you'll have 1 bin for every data point. You'll have 72 data points, 1 for each student. And that's not terribly useful usually. The one that was automatically chosen by the software is this one here. And that gives you a reasonable idea. Remember I said that the pattern with this particular class was that there was it's pretty much a bell-shaped group up to about, sort of from 53 up to about 80. And then there was another little group higher up. Now, the modern visualization that's commonly used is this thing called a kernel density plot or a density plot. And although it's not the way it's actually drawn, you can think of this as being the outline of a histogram that had an infinite number of bins. So it's a smooth line. And there's a very complicated mechanism behind actually drawing it, which I don't particularly understand. But one thing to note is that any software I've seen that draws density plots, the curve actually goes a bit beyond your actual data. So what I've done, and I apologise for this, I added these vertical dashed lines this afternoon. So if you downloaded the notes earlier, you probably didn't get them on your copy. But I put in vertical lines here for the 5 numbers. So you've got the minimum, the maximum, Q1, the median, and Q3, just so you can see how it matches up with the histogram and with the density plot. So density plots are pretty good by default at showing you important structural features of the data. But you can, as you can with histograms, you can tweak them. So they have a setting called bandwidth. And in the software, you can fiddle with that to show more or less detail. Now, let's... I'll just put... That's the same data again. I put little jittered data points there so you can sort of see where the data goes. This bit on the side, density, what that basically means is that, and we don't normally worry about this when we're looking at these, the way we use these in exploratory data analysis is we're just interested in the shape. But this is a thing called a probability density curve. So the probability of, being between Q1 and Q3 is the proportion of the area under the curve that's between Q1 and Q3. That's what it is. But don't worry about that unless you're interested, because I'm not going to ask you about that. So in the case of this data, basically what happened was there was a little group of students that did really well in the course. I haven't really investigated to see what special characteristics they had. Most of the students who were in the high distinction range did turn up pretty much every week for the classes, but I did the marking without knowing the names of the people I was marking, so it wasn't me rewarding my loyal followers. But they were not all in that category. So that's all. I mean, that's, given my experience looking at these things, because I do this all the time, that's not all that unusual as a distribution. There is a bit of a tendency for markers to be a bit shy about giving very high marks, particularly over 90. I'm not so shy about that. There's a very good reason why we have 20 marks for the high distinction range at ANU, and that's because it is reasonable to expect a few outliers at a high level. Okay. One big advantage of density plots is you can overlay them. Now that looks like a bit of a mess, but that's the marks from all the assessments for the course last year. And I can look at them and see, okay, yeah, somewhat hard. This test was harder than that one. The final exam, I think, was that one there. That's kind of pretty widespread. That's all fine. So, and then just for the heck of it, I've just put, again, same data. I've just put the histogram, the density plot, and the box plot, so you can see kind of how they match up. Now, I just want to talk a little bit about why we do exploratory data analysis and just a bit about where we're going with it. So, depending on who you sort of read about these things, people will talk about 3 things. They'll talk about exploratory data analysis. They will sometimes talk about initial data analysis, although that term is sort of going out of use and it's not being used very consistently anymore. and they will talk about confirmatory data analysis. So let me start with confirmatory data analysis. So confirmatory data analysis is what you do when you have designed an experiment or designed a study and you carry it out and you collect the data and then you do some analysis of it. So in the tutorial last week we looked at that article about noise in open plan offices. That was a carefully designed experiment. They collected the data, they analysed it mainly using a technique called a t-test. That is very different to just pure exploratory data analysis. But what they would have done, see, they would have done the experiment, and what they would have got is some sort of a download from those instruments they had connected to the subjects. And they initially would have done some exploratory data analysis. Now, some people would call what they did initial data analysis because it's initial to doing the statistical modelling that you do to analyse your experimental results. But generally these days we just call it exploratory data analysis. So what would they be doing? They would be looking for missing data, they would be looking for outliers, and with the kind of measurement they were doing, we know they found they had missing data. They may well have had outliers. Often when you're measuring human things with instruments, you get rather messy data. So they would have been looking for that. And then the other thing they would have been doing is checking that their data was the right shape for the t-test. So when you do a t-test, and we're not really going to learn how to do t-tests, but if you're really keen, I'll do a video to show you. But when you do a t-test, your data needs to be very roughly a bell curve. The way they describe it is it should be plausible that the data came from a bell curve from a normal distribution. And it should not have outliers, or at least not too many. Okay, so that's the kind of thing you check as part of your exploratory data analysis before you do the confirmatory data analysis. Pure exploratory data analysis, and that's really what I've mainly been interested in here. This is where you get some data from somewhere. It might be sales data from an online shopping site. It might be human resource data. It might be, data from the annual staff survey or something. What you're doing with exploratory data analysis is you're looking for patterns that might justify further investigation. You have to be very careful with finding patterns with exploratory data analysis because perfectly random data will have patterns in it, quite often. This can be a real trap. Particularly if you've got small amounts of data, you often will see patterns, but they don't really represent anything in the real world. But if you see a pattern that looks interesting, then it can warrant further investigation. An example that I'll give you is I did a consulting project about 15 years ago for it was a smallish government organisation, but a fairly high-profile one. And it was a simple job. It was what we call a staff survey. So a lot of organisations do this every year. Or every couple of years, you do a survey where they ask you about, your supervisors and your colleagues and whether you're overworked and a whole lot of stuff it's sort of like taking the temperature of the organisation. Pattern I observed in the data was the responses from women in part of the organisation were much more negative than from the men. And we started digging around and talking to people, and it ended up being a sort of Me Too situation with the CEO, which was awkward because that's who hired us. So that sort of thing is a kind of real world situation where a pattern might be significant. But you have to be careful, you can't jump to a conclusion, but you need to do further investigation. In the scientific realm, we will often get data and do exploratory analysis, and we will see patterns where we think, gee, that might be something interesting going on, and then you design an experiment or a further study where you actually test it. It's a mistake to give a lot of weight to things that you just find from data that's come to you. Okay. Now we'll talk more about that later in the course, but it's a very important thing to be careful about. You just need to be aware that sometimes beautiful patterns will appear and they mean nothing. And so you need to watch out for that. All right, that's really everything I wanted to cover today. Now, what's coming up? Oh, I was going to tell you where we're sort of going next with this. So we've looked at one quantitative variable. The next big thing in exploratory data analysis is looking for relationships between variables. So that is broadly what we call correlation. And so there are a couple of plots we use, a thing called a scatter plot, and we also can use bar charts, and we use box plots actually for looking for correlations. So we'll have a look at that, and I think that will be mostly what we'll be doing with the exploratory part of things. And then we'll move on to, I'm going to teach you a couple of 2 or 3 confirmatory techniques, but I've chosen ones that you can use without having to either do really complex calculations or having to know a lot about things like the shape of distributions and so on. That's why I don't teach the t-test, because even though it's a fairly simple thing to do, you have to know about probability distributions and something called degrees of freedom, and you have to know and some idea of how to test for this thing, the idea that something is approximately normal and all of that sort of stuff. So the trouble is that to do that, I'd basically use up maybe a couple of lectures, and I've got another way of doing that doesn't involve all that stuff. So we'll do that one, and then if you want to go and learn this, the good thing is that if you then want to go and learn some of these other techniques, there's no end of resources available on the internet where you can learn them. So if you want to learn how to do t-tests, it's pretty easy to find out how to do it. So, all right, so that's it for today. I've actually finished a little early. Do we have any questions, concerns? Yes?
So you have said on the WeChat group that you will provide us an example for the task write-up and the exam.
So what I did today was, I think, cover everything you needed to know for the task write-up. You can't, let me just say, you can't do your task write-up about job selection. But if that puts you in a difficult position, like if you've already written and it's about job selection, you just email me and we'll work that out. But no, there's nothing, so let me try and be clear about this. None of this stuff I said about measurement today is going to be in the test. Okay? That's just, I'm just preparing the ground for things we're coming to later. You'll learn it better if you sort of get, even though it's not going to be totally clear at first, you'll learn it better if you start getting introduced to it as we go along. So the main thing what I'm looking for in that task write-up, it's all about how MCDM is used as an adaptation or a compromise from the pure rational choice version of things. So if you can give a clear explanation with an example. Let me just say a couple of other things about test questions. Some test questions will ask you to give an example. There are always students, usually 10 to 20%, who answer the question and don't give the example. In general, you're not going to get any marks for the question if you don't give the example. So if it asks, just watch this very carefully. If it asks you to give an example, make sure you give the example. That's probably the biggest single thing that happens. Another thing that happens, I think, I'm not sure what goes on here, but I think sometimes students just miss a question, and it's probably something to do with having, typing it onto a screen under time pressure or something, but just check that you actually did answer every question. What else is there? Please do not delete the questions from the test paper. So when I'm marking it, I know they're going to be numbered, but I'd like to have the thing in front of me while I'm reading your answers, so let's not go and delete them. Remember to paste in your task write-up. There's always a few students that forget to do that, and then I get an email right after the test saying, oops. You just paste in it, so you've got to do this task write-up thing. I'll just have a space in the test paper. You just paste it in. So it's just one document. There won't be any way of submitting 2 documents, so just submit one document. Do make sure that your student number is in the paper, but not your name. Okay, I want to mark things anonymously, but do make sure your student number is there. What you'll actually see is question 1 says, what is your student number? And question 2 says, did you answer question 1? If not, because every time, and it's a pain trying to figure it out. You can, but it's the way Turnitin works is it's not that easy. It's very difficult to work out whose paper is what. So I need to have your student number on it. There was one other thing. What was it?
How many questions?
Well, to be honest, I haven't finished writing it yet because I wanted to see how much I got through today. But I don't think it probably won't be more than 10. Yeah, no, it's. But some of them will have a few parts to them. But as I've said before, I do not believe in having tests that are like a time trial. It's pointless in my. So this comes down to, validity, trueness with test measurement. If you have, I know some lecturers believe in having tests where there's just more questions than anyone could possibly answer. I just can't see the point of that. I mean, unless there is some reason for measuring speed. So if the aim is to measure the speed at which students can answer questions, then that's why I don't get it. I'd rather people were relaxed. Generally, when I've set sit-down tests in the past, I'll write a 1-hour test and give everyone 2 hours. And what happens is 3/4 of the class are out of there in an hour, and there's always 2 students that are there right to the end, checking and rechecking and rechecking. But good on them, I don't have a problem with that. Oh, I know what I was going to say. So here's what I normally do with these online tests is I get myself online half an hour before, and I sit there anxiously waiting for people to start, hoping nothing goes wrong with Wattle and all that sort of stuff. It so happens that this Thursday at 10:45 a.m, 15 minutes before the test, I have my second AstraZeneca shot for COVID. Now, when I had the first one, the clinic I went to, they were absolutely on time. It took about 5 minutes and I was out. So I will have my phone with me, I'll have my computer with me. But if there is a technical disaster, don't freak out, I won't be far away. And if for some reason, I've done everything I could to set up so everything just happens automatically. But if something goes wrong, if for some reason you discover you can't get the test, it's not there, it's invisible, I will fix it and I'll just give you extra time, okay? So, what else can I say about it? I think that's it. Make sure when you're writing the answers, you hit the save button regularly. There's always one student that manages to lose the whole test. But look, no, mostly it seems to go pretty smoothly, and I think probably by now you're all much more used to this whole online thing. I certainly get that impression from the class as a whole this time. People have kind of got used to it, so don't worry about it too much. I'm really just using the test to, I have to mark you. I've got to produce a mark at the end of the course. it's feedback for you and it's feedback for me, which is really important too. So what is likely to happen is on Thursday is I will put my phone in my pocket while I go and get my vaccine, and then I'll be around. I'll be watching to see what happens. So I shouldn't be out of action for more than 15 minutes. Okay. All right. Well, thank you everyone, and good luck.
Thank you.
And we'll see you next week.
I still have a question on this.
On
It's like,
Yeah.
You said about the word limit. Is that for each question or for like the whole one?
No. So don't worry too much about word limits. When I say word limits, I usually what I'll do is with each question I'll say something like you should be able to answer this in a few sentences, or it's just sometimes what will happen if you don't do that is you'll have a question which can be answered in one sentence, and some student will maybe misunderstand it a bit or something, or they feel that if they write a page, it's going to be a better answer. So I try to just give a bit of guidance. It's just about trying to manage the anxiety in the exam situation. Yeah. Thank you.